when does that event have to fire? Could you tell me that? When will it fire? At the final time. Now, so where can we find an event to add to the model? Where in the palette? Indeed, in the agent. We'll go add event, and this will be, event populate income versus infection count scatterplot, something like that. Okay, this will go off only once and at time what? Sorry? 5,000. Now, I mean, there's another place we could, be kind of nice if you could declaratively say to this, for this event, go off at the final time of the model. So we didn't have to hard code it. That troubles me as a software engineer, hard coding, saying 5,000, because maybe later we'll decide to run it to 10,000, and this won't be automatically updated. That's a very good question. Let's try this. This dot model. There is actually. I think there is. Let's give it a try. It's called, get. I should know this. Is it get end time? Is Dylan here? Dylan, could you find this? Also, Anatoly will probably know this right off the bat. To find out the end time of a given model run, it's I'm trying to remember the name of that. Get engine and then get end time. Get engine dot get end. No dot got finish. No. Get stop time.
There we go.
Okay, thank you, Anatoly. Get stop time.
Yeah.
There we go. Great. Thank you. Thank you for all who made that suggestion possible. Thanks very much. Okay, great. So that will be the first occurrence time of this event. It'll be at the stop time of the model. Now that's much more robust, because if we later go change it, or if different experiments have different stop times, it'll be used accordingly. Let me put that up on the big screen. There you go. This is main. Okay, I'm saying get my engine. The engine is kind of the Anylogic engine of power, and then you say dot get stop time. This is a reference to the so-called engine of Anylogic that maintains a lot of basic quantities. Okay? You say get stop time. People okay with that?
Yep.
Okay. So what's the key thing though? So is that all we have to specify for that event? Far from it. What else do we have to specify? Yeah, we have to specify an action. Okay? Now, you can tell me, what does this action need to do?
I have a question about that get stop time.
Yes?
Is this going to run it just before the last instance or just after the last instance?
It'll run it at precisely the last time.
So will it pick up the income of the last person?
Yes, it will. Yeah. It's running it at the last sort of infinitesimal little bit of time. So yeah. Okay. So what do we have to do here? Well, probably for safekeeping, we should clear this this data set. And I don't know. Yes, there's a reset here. So we reset the data set. And then what do we have to do? What are we seeking to plot out? We're trying to escape the tyranny of aggregates, this subjugation of the stories of individuals to the sort of high level summaries, the high level sort of impoverished totals up over the population, something that we know hides in health, hides terrible disparities sometimes. So what do we need to do to bring out those histories of individual lives of persons, to capture the voices of individuals? What do we have to do here? Okay, we have to go over the population one by one by one and add what for each of them? Add their income and the number of the count which they're infected. So my preference would be to do this as follows. Population dot for each person that's handled by this for each, what do I want to do? I want to add to what? To the data set dot add, and you notice you can specify an X and Y value to a data set. And what will that, you could see this, control space, it tells me the X and Y values. And what do we add as the X value? Yeah, person dot income. It's the income for this particular person. What will we add as the Y value? Person dot count times infected. Okay, I will put this up on the big screen. And that, ladies and gentlemen, is all there is to it. Yeah. It's equivalent. It's well, yes. It's basically equivalent. There's there's differences in the aesthetics of it. There's also differences in the mechanisms. There's probably a slight difference. I don't believe it's much in the performance. But this is a mechanism that's particularly elegant for doing it all in one line. How would I write this? Let's go write this in a classic style here. How would I do that? For person in population, I could write, and otherwise it would be just the same thing. It'll be this. That's exactly what it would. Excuse me. I don't need this thing there. That's what it would be. The equivalent. This is sort of a classic way of writing this. Now, there are certain cases where each of these, in my view, has manifest strength. In other words, is much clearly better. This is one where I think it's a little bit arguable, but I wanted you to feel comfortable with both, so I'm showing you both. I wanted to build your strengths in both, so then you can choose for you what you feel is better. Okay? Give you your comfort. But I will say this top one, the one which we actually used here, that one's going to be in use ever more for certain types of needs, and we'll see it more tomorrow with some very powerful things. It would be very awkward to write in this. It would be the top one? Really? Okay. That's terrific. Dylan, make note of that.
What was that?
She liked this top one more. Yeah. Okay. So actually, this is actually really helpful, and I'm going to ask Dylan, because I don't want respondent bias driven by the interviewer. I'm going to turn my back, and I'm going to ask. Well, okay, Dylan, you're also. I'm sorry, but you're also. We're going to have to turn our backs.
So you don't. Oh yeah, I suppose so.
Yeah.
Everybody.
Yeah. Okay.
All right.
Jeff, could you don't have a dog in this fight. So could you count the number of people who prefer this one to this one, just to give us a feel, because we are like 3 standard deviations out on the nerdiness scale, and we carry cherished prejudice with us. Could you count?
Okay.
Okay, so Dylan and I will hide behind the pillar. Okay, so how many prefer, I'm not looking in the reflection of these windows, how many prefer the top one? Okay, how many prefer the second one? How many don't care one way or the other? Or find both so hideous to not like them? Okay, Jeff, can you roughly tally up?
I can exactly tell you. It's right down the middle. Should you include the dark shade?
That's very interesting. That's very interesting. Thank you very much for everyone for voting. And actually, I'm in this particular case, I don't know about you, Dylan. I slightly prefer the top one, but this one is not bad. But there are cases where the bottom will be terrible. And we will be spared even tomorrow from the ravages of the bottom by recourse to the top. What's that? Because it would involve so much mechanism and cruft, it would be very distracting and you couldn't see really what's going on logically. It'll involve several steps of sort of looping through and filtering, looping through and counting. And you'll look at it and it won't be obvious what it's doing, but if you write it in a single line form, it'll be clear, oh, that's exactly what it's doing. At first, filtering people by this characteristic, then for each person it's extracting this information, and then it's summing those up or taking the average of that. Whereas you'd have to write it as like 3 different loops.
How would you do that in line?
You
Without
do.
looking complicated?
Oh, it's a thing of beauty. You do something like this. You do something like this. So you do something like connections.getStream.filter person. So if the person is over 18 years old, then we'll consider them, and then maybe we will map for the person. We will make use of their income, and then we'll take the average of their income. So here we filter out, we find the people who are over 18. For them, we get their income, and then we take the average over those incomes. Do you prefer? Sorry? For performance testing? Oh, sure. These are no problem. Performance ones. Streams? They're part of Java 8. They're really well supported. Yeah. Streams are extremely elegant ways of doing these tests, of doing these calculations. And doing them in for loops it's problematic for 2 reasons. The first thing is the aesthetics, but the second thing is that streams can be parallelized. They can be parallelized so they can be performed in at the same time concurrently, which can allow you, if you have large number of data items, to secure very large economies in terms of the time it takes to compute them. So they're very favorable in terms of processing large amounts of data. Okay, so here we have this case of a bit of code to populate this this data set, and then the data set is going to populate this scatterplot. Okay, so let's go run this. So why don't we see the scatter plot right now? Yeah, because we haven't finished the simulation. Now we're finishing the simulation, but we see it's not exactly transparent because we forgot one more option with the scatter plot, and I apologize to mention it. If you scroll down in the scatter plot, you will find that there's a thing that says draw line, and you need to uncheck draw line. So uncheck the draw line for the scatter plot. Okay. So there we go. And this is our scatter plot, ladies and gentlemen. Help, TA help, towards the front. Okay, so what does our scatter plot show us? Sorry? Yes, infection is more in the low income group. And you'll actually see a very sharp drop off here. Very sharp drop off, you know, and as the income rises below about maybe 2,000. And after that, it's virtually what? Virtually zero. Let's see if we can zoom in a little bit. Let's go see the scale, and let's go see if we can specify a horizontal scale that's fixed between 0 and 2,000. Is that okay? What did I just do? I went to select the scatter plot, I went to scroll down to scale, and I went to say this horizontal scale is fixed from 0 to 2,000. Is that okay? Okay, great. Excellent. Okay. Let's go run these things. Okay. There we go. That's what we see. From 0 to 2,000. What does that suggest, ladies and gentlemen? Sorry? Yeah, as your income increases, you're going to typically have fewer infection counts over the course of the run. Now, of course, I've truncated. What lies beyond 2,000? Essentially zeros.
Non-academics?
Well,
You're not doing a very
that's
good
true.
job. You're not doing a very good job of convincing PhD students to continue in this line.
So, PhD students enjoy many additional noble motivations. Yes?
Does it allow you to label those axes?
That's a good question. Excellent question. So let's go take a look at this. So I honestly don't know. I believe there may be an option. Yes, legend. Here we go. Legend and oh, sorry. That's not the legend. Oh, okay. Okay, that's too bad. That's too bad. Note that, by the way, you could put metadata in the description here, so you can actually sort of comment. But that's just to sort of comment to people who may be browsing the model. Here, I don't see a way, as Dale said, to do this. One thing you could say in the data set title is, you know, income horizontal versus infection count vertical, something along those lines. And then that would at least be somewhat evident, right? So here we go. So we're running this, and there we go. And so now at least it's more clear, right? Okay. So each of these dots represents what? Just to make sure we're in sync. Each of those dots represents a person, and it summarizes their experience over the course of the the full simulation, right? One of these attributes, which is it, is static and does not change in the course of the simulation. The income. I'm working on models right now back home where the income does change. It evolves, reflects people's income and their family, or excuse me, their people's education, their family status, etc. But inheritance, etc. But here it's static. But on the y-axis, what do we see? The cumulative infection count, the number of times they've gotten exposed. And what this is clearly showing us, well, and especially once you consider those outside of the scope, is that we have successively less exposure as the income goes up. And it's really in this bottom area that you see a really substantive gradient with income being really apparent. And that extends out to the low thousands of dollars, where we define the poverty threshold, or this threshold of high versus low, as being about here, about 400, right? But over here to the left, there still continues to be some gradient. This is driven by stochastics, right? If I ran this again with a different random number seed, I'd see a slightly different thing. Do you think it would be similar in its general slope, its general appearance? Well, let's run it. Can we run it? Let's go. And how would I set it so that this doesn't use the same random number seed? It actually varies each time. How would I set it so that it varies each time? Okay, yeah, exactly. We go down to randomness section of the experiment, and we'll say, to use random number seed. Okay, so can we run it? What do you think we'll see? Will it be similar or different? Given all the stochastics, which do you think it will be? Yeah, it's going to be very similar. A little bit different. Here it actually looks like it's extending a little bit further out, right? So maybe that threshold of 2,000 was a bit premature, right? But you see that again you have this sort of gradient, and in this region it's not quite as tightly delineated slope-wise, but it's a sobering graph. And this represents at a deep level the influence of what? It's of income, but income mediated by what? By what pathway? By cropping, right? The fact that we join together people. Dale, you had a question? Exactly.
And since the higher income level, the more likely you are to be separated into small groups.
That exactly.
Now, when we want to vary something, we use a parameter. Say we want to modify contact rate. But in the case of a network type, a network distance is defined inside the population.
Yes.
The assumption of 75 or 100.
Yes.
We want to change that.
Yeah.
But it's not essentially like a normal parameter. Is there a way we can have a varying experiment without having to always go through and modify in main the population?
In other words, is there a way to get it to sort of vary it without manually going in there and sort of adjusting it?
Well,
Yeah.
say we want to verify, we make a new experiment, like
Yeah.
say contact rate on food, but here the network
Yeah.
defined distance
Yeah.
income is defined in the population.
Indeed.
In main.
Indeed.
And so it's then you change for all the experiments.
Indeed.
So can we define a parameter and then assign that parameter?
Yeah, I think so. I could take a look at that in just a moment here. I like that idea, and I'll see if I can look at it briefly. And actually, maybe that's something Anatoly could say off the top of his head, or others who have had high experience with Anylogic here. Can you, through the API, say, use this connection threshold and then recalculate the network for a distance-based network? You happen to remember that off the top of your head through the API? I think so too. That's my recollection. We'll go check that in just a minute. Okay, so I've just shown now the impact of this dual intervention where we have both interventions going on. Do you remember that? Remember we had this dual intervention where we lowered simultaneously the contact rate and the infection threshold? And you'll notice that the gradient is a little bit different here. Why is it so different? Why is it banded even? The answer may be apparent once you look at the changed scale of the y-axis. What differs in the y-axis? What's notable about this y-axis compared to the one that I just showed previously? It's the other one went up to where? Let's just go rehearse this. Watch this one. Pay attention to that. And now let's go to the baseline and let's watch it. Okay, here we go. What's different about the y-axis? This is hugely larger, by about an order of magnitude, more than an order of magnitude larger. For this case of the dual interventions, the y-axis is in fact quantized because we're at a level of resolution that's the level of individual times of infection become really evident. We're going up. Then people at 0 cumulative counts of infection, 1, 2, 3, 4. That's why it's quantized. And you see it divided into these bands with a clear gradient, once again. A clear gradient reflecting crowding and the adversity that emerges from it for infection, for vulnerability to infection. Okay, so ladies and gentlemen, I'm trying to shape this general event to be responsive to your questions. And the questions that came earlier about how do you analyze things, I'm trying to give some sense about some of the mechanisms you have within Anylogic to experiment. And I think you'd all agree that having recourse to these things within Anylogic to allow you to run an experiment and see the result, run an experiment and see the result is useful. But we also know that we have recourse to very powerful tools externally, tools that afford us quite a bit more in the way of specialized analyses. Perhaps we want to produce Kaplan-Meier survival curves, perhaps specialized box plots, etc. And we may want to subject our data to other sorts of analysis, hex bin plots, specialized maybe tests associated with QQ plots, etc. And for that, it's best to export the data. Okay, but these are the results for different runs, and it's an interesting way of summarizing it. And I credit Dylan with the foresight and the prescience to suggest it. Very good. Okay, so let me stop this.